So we're factoring. Factor. This will finish it off, okay? So. Being slow today? No being slow, right? No. I haven't mentioned this, but the first thing you want to look for is there a constant? Yeah. Yes or no? Therefore, that's a U. What's a U? Okay, let me make it easy on you. No constant, right? So I can factor a U out, right? Yeah. All right. So the first thing you want to always check for is, can I factor out something like that? Makes it easy. It makes me get a 0 of 0, right? So always check. That. We've run into it already, but I mentioned it. We're going to look at quadratic impersonation. It's Halloween almost, right? So these like to dress up as quadratics. Then we're going to do the sum and difference of squares and sum and difference of cubes. They're just algorithms. If you have it, all you basically just follow the rule. Okay? So, these are basically dressed up quadratics. We factor them just like you would factor a quadratic. Okay, so that's fancy little constant on. All you gotta do is recognize that. Okay. So something like this. You know that quadratic, right? Can you factor it? Ready to go? Anybody? No. You can? Okay, it's just a quadratic. What are the factors? Multiply to get negative 12 and add 4. Right? Quadratic and then factor. Okay. Yeah? I'll write that one down. You're worrying me here. It's Monday. Okay. So I'm going to dress it up in its costume. Monday. It's not Monday, it's Wednesday. It's still Monday. Yeah. And we haven't answered. Okay, here it is, dressed up. Got fancy little hat on now. This is an impersonator. Because it is very similar to this. Notice the 2, 1, and then this would be x is 0, right? This is 4, 2, x is 0. So what you're looking at, does the second one cut the first one in half? Okay. What are the factors? Squared plus 4. And squared minus 3. So if you're seeing 3 terms, this is one of those 3-term methods. 1, 2, 3 terms. You can try to factor it like a quadratic. So the exponent changes on the x. Does that change how it's going to change the graph as well? This graph would be different. Well, see, the fundamental theorem of algebra, you have two x-intercepts in the graph, right? So this one is at -4 and +3. So it's going to look something like that, right? This one, we have a 0 at positive or negative √3, right? We can add 3 and square root it. But this one is an imaginary loop. Square root of -4. It's going to look very similar to that original graph. But it might do something like this. And I don't know if this is accurate or not. See how it's a fundamental theorem of algebra is 4 complex roots. 2 are real, and then we have to have 2 complex. So that's probably what that looks like. That's your question? Is it any different? No, what are the factors? Is it? Yeah, ready? Remember when you're multiplying exponents? Oh, yeah. You can add the numbers. Right, so if we have the same base and we multiply those together, we add the exponents. So remember that. Okay, so that's a quadratic impersonator. It's just got a fancy little add-on. Okay? Of course, that principle will let us do that here. So, you think you can handle those? I mean, they're all pretty straightforward here. You probably won't run into it very often, but in case you didn't care. Alright. Okay, some basic algorithms that can make your life really easy if you can recognize these. So, that is called the difference. Difference means subtraction, right? The difference is subtraction, and are these both squares? Yeah, is this 4 squared, right? Easy way to factor these is just a straight algorithm. Done. What are you talking about? I'm a genius. I have 4 little friends call me around with John Nash. And we have to see. So, if you see 2 different squares, subtracted x minus 4x plus 4, this one. You can, if you want to, you can add a 0x in there and still factor it like normal. What multiplies to get 16? Negative 16 and adds to get 0. Negative 4 and positive. So you get the same result. But if you can recognize this, your money makes it easy. Okay? So maybe something like enough fun. He's tired of math. It's always enough fun, so it's tired of math. Right. What are our factors here? If you need to, you can rewrite it. 5 squared is 25 and 8 squared is 64. If you need to rewrite it, now it's very obvious, right? Okay, that's minus 5y. Okay, that's plus 5y. So it's I can do 64 squared plus 25 squared. Plus? You can't do plus. Because the reason this works is because these are opposite signs. In order for the middle to cancel out. So in order for that to be 0, we have to have a plus and a minus. So this would be plus 4x and minus 4x. See that? So if they were both positive, that's why the difference of sum of squares doesn't work. Okay, so just the difference of squares. Okay. But we will see. Are we good here? Yes. Here's the paragraph. Just like 6. I just wanted to get in the field position. You do have the sum of cubes that works though, and difference does as well. And I always have to look these up, so they're just it's an algorithm that you follow. So we're going to have something. So, well, something like that. It's just like the difference is squared, right? So, what we end up with is a binomial and a trinomial. All you're with, remember it's a sign. So this is the test you want to not let me forget to give you another sheet. Next week, so let's see if I can help. Fraction. Take your time, just wasting your homework time, right? You have already get over. This is why I should memorize this stuff. We'll just go to the internet, the all-powerful internet. Minus plus plus. Plus minus plus, okay. So it's just a sign change here. Notice these signs match. So maybe I give you something like that. What is B? need to rewrite it. A is x, b is 4, right? So x minus 4, x squared plus 4x plus 16. And you have the factors. So if you got these algorithms with you can factor cubics a lot easier. Hate to try to pull out out of my brain without it. Can we factor this? Okay, so. Yeah, I'm pretty sure we can. Feel free to prove me wrong. Okay, so that's the difference of cubes. Here's the sum. Notice that this is sign change. So just take that maybe. Plus minus plus. Nope, it's right. So again, just notice the signs match here and they match here and here. There's always one negative. Okay, there's another pattern. There's always one negative. Right. So if you want to try to memorize these, you can, but it's not required at this stage. Here's the sum of two cubes. If you need to rewrite it, 2 cubed is 8, and then 3 cubed is 27. I've always found it handy to have the cubics memorized up to 2, 3, 4, 5, 6, 7. If you're a math nerd, fine, whatever. I don't bother with it. So we just plug these in. 2x plus 3. And we have 2x squared. Don't forget, put the 2x in parentheses. Okay, that's that whole term. Minus 6x plus 9. So that would be 4x squared. Be careful there. You have to turn that back. Any questions? You want to see any others? These are plug and chugs. You can get this. The plug and chug algorithm. This, the 2x in parentheses. This is that term squared, right? Yeah, if I were to rewrite this, that's what I would rewrite that. Same thing. Save that. You guys are okay? You should have plenty of time to finish this. The back side of the sheet is a free-for-all. It doesn't say factor by grouping or etc. It just says factor. It says hard. Yes, I'm playing with your minds. Yep. Right. So you have this, the odds, this is the odds, and then the notebook. Just 20 minutes, if you have any questions, ask somebody else. Might be similar. If you have any questions, let me know. I'll give it my best shot. Whoops. Okay.